All right, y'all. So like I said, this is 6B homework. And there'll be places in here where I'm going to have y'all sort of help me work on these when we get to the actual problems involving the math. So this first question, describe how the range of a distribution is defined and calculated. So they're talking about the range. So I'm going to put the answers up here that they gave us. So for number one, let me let one in real quick. So for number one, the answers they gave us for range were the range of a data set is the difference between its median and most extreme value. Well, that's definitely false. The range of a data set is the difference between its highest and lowest data values. So that's what we said the other day. So on that one, you want to definitely go with B because we said the range was a difference between the highest and lowest data value. That says it divides it, no. And then this one says it divides it, that one's no. So the only answer on there that was correct for the range was that it's the difference between the highest and lowest data values. So difference of highest and lowest data values. So number two says, define the 5-number summary. So they want me to define the 5-number summary. And explain how to depict it visually with a box plot. So remember, the 5-number summary was my lowest data value, my first quartile or the lower quartile, the second quartile, which we called the middle quartile. You had a upper quartile, which was the third quartile, and then you had the whisker going out to the right, which was the highest data value. So let's look at their answers on what they came up with for the 5-number summary. So here we got low value, variance. Well, that's not it because it don't have nothing to do with the variance and the standard deviation. Same thing here, they got variance again and standard deviation, so we know it's not that one. So C says low value, lower quartile, median. Remember, the median is that middle quartile, actually. The upper quartile and the high value. So C named them off just how I needed them. Now watch for the difference on D. D says low value, lower quartile. Those are right. But then it has mean. We didn't find the mean on the box plots. Remember, the middle line was the median, not the mean. And then everything else is the same. So you got to watch for that, okay? The box plot deals with the medians and not those means. Then down here it says, how do we do the box plot? So this says draw a number line that spans all the values in the data set, enclose the values from the lower to upper quartile in a box. Well, you got to do a lot more than that, so it can't be A. B says draw a number line that spans all the values, enclose the values from the lower and upper quartiles in a box. That's true. Draw a vertical line through the box at the mean. So, oh, they said the mean word again, so that takes B out of the answers. Remember, it's not the mean, it's the median. So let's see what C says. Number 9, it spans all the values. Enclose the values from the lower and upper quartiles in a box. That's true. Draw a vertical line through the box at the mean. Well, that's false because we can't use the mean. So it's got to be D. So let's see what we get. Draw a number line that spans all the values. So that means they're doing all the values. Here's your low value and your high value. Enclose the values from the lower and upper quartile in a box. So that was making a box like this. This end was the lower quartile. This end was the higher quartile. Draw a vertical line through the box at the median. So we would draw a line through there for our median. Add whiskers extending to the low and high values. So that's our low and high values. That's our whiskers coming off of the box. So it has to be D for that one. And y'all, the key word on this was the median versus the mean, like they had on that answer B, okay? So these are all medians. The median in the center of the box is the median of all the data set. The median for the lower quartile is a median for the lower half. And then the median at the high quartile was the median of the upper half of the data. All right, y'all. So just remember on the 5-number summary, it's the low value, lower quartile. The median, which is the same as the middle quartile. Then you had your upper quartile. And then your high value. All righty. So those first two were just mainly getting you used to the definitions that you've seen on the box plot. So the third thing we talked about Monday was the standard deviation. So this question here, so let me write standard deviation. So this question says, describe the process of calculating a standard deviation. Give a simple example of its calculations. And they're telling me to find the standard deviation on the numbers. So the numbers they want me to use are 2, 3, 4, 4, and 6. So they sort of want us to describe the process as we're going through here, okay? So I'm going to write the page down. So they want me to fill in the blanks to complete the process of finding the standard deviation. So first we got to compute the mean of the data set. So I'll let y'all sort of tell me, how would y'all compute the mean of that data set? So any ideas on that one? Oh, I'm looking for chats or anything. So I don't have my chatty guy on here today, do I? All right, y'all. So here's what we're going to do. Oh, let me let one in real quick. Naples. So I'm going to tell you how to find the mean. To find the mean of this data set, 2, 3, 4, 4, and 6. So the first thing I'm going to do is come over here and find the mean. To find the mean, I'm going to add those 5 numbers together and then divide by 5. So 2 plus 3 plus 4 plus 4 plus 6. That gives me a total of 19. And I'm going to divide that by 5 because that's how many numbers I had. So let's see, that gave me 3.8. So our mean is 3.8. So that's the first thing it said, compute the mean, which was 3.8. Then find the deviation from the mean for every data value by, your choices are going to be dividing the mean, subtracting the mean, multiplying the mean, or adding the mean. Blank the data value. So remember the other day, I had all my X's. To get that next column of numbers, I subtracted the mean. So we subtracted the mean. From the data value. So let's do that real quick. Let's write all of our X's, which are 2, 3, 4, 4, and 6. And remember, the next column is going to be my X minus those means. So I'm going to take each one of these X's and subtract 3.8 from it. So some of these are going to be negative and some of these are going to be positive. So 2 minus 3.8 give me negative 1.8. 3 minus 3.8 gives me a negative 0.8. 4 minus 3.8 gives me, oh, what's that, a 0.2. So I'm going to have another 0.2 because that's the same data value. And then 6 minus 3.8 is going to give me 2.2. So these are all the deviations. Remember, the negative ones mean they're lower than the mean. The positive ones mean these numbers were higher than the mean. And that's how much higher or lower they were than our average. So we got that part. So then it comes in here and it says, find the blank of all the deviations from the mean. So that could either be cube roots, cubes, squares, or square roots. So y'all, what did I do the other day when I found all those deviations? Do y'all remember? Oh, y'all are just so quiet today. So how about, of these choices, we are going to square each of those numbers. So we're going to find the squares. So y'all, that's when I came in here and I made the next column, my X minus my means squared. So take all these numbers and multiply times themselves to square them. They're all going to be positive because a negative times a negative is going to give us a positive, just like when we do a positive times itself. So you can do negative 1.8 times negative 1.8. You can do them like that and get a 3.24. Or you can square them using the calculator. But remember, the negative numbers, when you square them, put those in parentheses. So I could have did negative 1.8 and squared that, and I'm still going to get 3.24. All right, so let's do this one. Negative 0.8, square that, I get 0.64. 0.2, when I square that, I get 0.04. So I'm going to get that twice. And then 2.2, square that. Now, the positive numbers, I don't need to put parentheses. And that gave me what, a 4.84. All righty, so I've got them all squared. Still, then it says, and then blank them together. So once I did all the squares like we just did, then we're going to either multiply or add them together. So we're going to add them all together. So we came in over here and drew a line down here and put our sum. So that's going to equal that line of numbers added together. So let's see, 3.24 plus 0.64 plus 0.04 plus 0.04 plus 4.84. Add all of them together and I get, looks like an 8.8. All righty, so let's look over here. We added them all together. That gave me 8.8. So then it says, divide this sum by the blank. So the choices are total number of data values minus 1, total number of data values minus 2, total number of data values. So does anyone on here remember which one of those I did? All right, so I'm going to look at the chat real quick. So let's see. Oh, no, not the total number of data values. It's going to be actually the number of data values minus 1. Okay, so remember, we're looking at that formula we did over here, remember? On the top was the sum of deviation squared. And on the bottom, we had the values minus 1. So go with the total values minus 1. So what they're saying now is I would take this 8.8 and divide by the total values, which I had 1, 2, 3, 4, 5 numbers. So 5 minus 1 would give me 4. So what they're doing here, they're doing it out in steps. If you remember the other day when I was using my calculator, I used the square root and put everything under it. So they're just going by steps for this problem because they're sort of having you work it all the way out. So y'all, that 8.8, we're going to divide by 4, and that gives us 2.2. So at this moment, we got 2.2 after we did that, adding them together and then dividing them. So then the last process, it says, the standard deviation is the blank of this quotient. It's going to be the cube root, square, square root, cube, or fourth root. What would y'all go with? Oh, let's see. So yeah, someone on there saying the square root, and that's what that thing's doing. It's going to do the square root. So good job. That's the square root. So that 2.2 that I had a while ago, I'm now going to take the square root of that 2.2 and see what that gives us. So the square root is the second x squared t that brings up that square root, and then put in 2.2. And that's going to give me, let's see how far they're going on. Oh, I'm just going to go a couple decimal places, it looks like. So what's that? 1.483. So I'm going to keep that at a 1.48. So that would be our standard deviation. So here it says the standard deviation of those numbers, oh, okay, they went 3 decimal places. So let me bring that back. 3 decimal places will be 1.483. So that would be 1.483. Now check this out. If all the data values were the same, so if they were all 5, so if you had 5 5s, then the standard deviation is what? Well, y'all, if they're all the same, that means your mean will be all these added together, which is 25, divided by 5, which means the mean is 5. So each one of these will be 5 minus 5, which is 0 for the deviations. There's not going to be no deviations if they're all the same as the mean. So if there's no deviations from the mean, that means it would be 0, okay? All right, y'all, so you sort of want you to work with those numbers they're giving you and sort of go through it and tell them how you found that standard deviation. All righty, so let me see what my number 4 holds. So they want you to decide, does this make sense, which is clearly true, or if it doesn't make sense and it's clearly false? And then sort of explain your reasoning. So this says both exams had the same range. So both exams had the same range. So they must have had the same median. So think about it. The range is just a difference between the highest and low numbers. So the difference between, say, 50 and 10, 50 minus 10 would be 40, which means its median might be somewhere in between there. But what if my range was from 60 to 100? It still has a range of 40, but that median is going to be a lot higher than the first median because my numbers are between, what I say, 60 and 100. So my median would be in between those. So just because they have the same range has nothing to do with the median. So on here, there are little choices. They said it makes sense because the median is equal to half the range. Well, that's false. Whoops. I don't want to, I just want to take that answer out. It's not happening. This one says it does not make sense, which is what we said, because the range is the difference between the high and low values. It has nothing to do with the median. So that's the choice you want. And then let's see what C and D say. It doesn't make sense because the range is the most common value or group of values. False. That would be the mode. It has, so that one's not happening. And then D, this makes sense because the median is equal to the range. Definitely not. So the only one it could have been was the B, where they said that the range was the high and low values, and it had nothing to do with that median, okay? Right, so I want to sort of skip through, 'cause I want to get to some of these, where they want us to compare a few things. So I'm gonna turn this over so we can get this data wrote down. So let me show you what they're giving us. They're giving us this table, East Coast counties, A, B, C, D, E, F, and their values, and then Midwest counties and their values. It's the cost of living index for 6 East Coast counties and 6 Midwest counties. And they're using an index where 100 represents the average cost of living for all participating cities with a population more than 1.5 million. So they want me to answer A through E. So this is one of the problems I definitely wanted to go with to you. So let's write down this data. So I got my East Coast, and then we'll have our Midwest. And I don't even care about the ABC stuff. I just want those numbers. I want the 104.5, 128.3, 314.1, 134.5, 123.5, 141.6. Now they just had this A, B, C, D, E, F just to represent the different counties. For the Midwest, let's see, I want my 96.1, 92.7, 94.2, 87.8, 95.2, 228.9. So the first thing they want us to do for A, find the mean, median, and range for each. So we'll come down here and do East Coast. Oh, let me let one in real quick. All right. So I'm going to find the mean of each of these first. So to find the mean, I'm going to add all these together and divide by 6. So for the mean, you do divide by how many you had. Standard deviation is where you had to subtract 1, okay? All right, so let's add these together. So clear, so I have 104.5 plus 128.3, 314.1, 134.5, 123.5, and 141.6. That gives me a total of 946.5. I'm now going to divide that by 6 and get my mean, which is, so first mean for this side is 157.75. Remember, that mean's got to be below your lowest number, which was the 104.5 and 314. It's got to be between those two to be the average. All right, let's see what else they want. Then they want the median and the range. So let me find this mean first over here, and then we'll do the medians for each, and then the range. So I'm going to do the mean of the Midwest now. So add these 6 numbers together, divide by 6. 96.1, 92.7, 94.2, 87.8, 95.2, and then the big one, 228.9. When I added all them together, I got 694.9. divide that by 6. And I'm going to round 2 decimal places like I did that one. So I'm going to go 115.82. So 115.82. Now remember, I showed y'all the other night how y'all can find mean, median, standard deviation on that calculator using the stat stuff, okay? Oh, it wants the median. So to find the median, I got to put these in order. So let's put them in order from low to high. So I got 104.5. What's next? 123.5. Let's see, 128.3. Then what I got? 134.5. 141.6. And finally, 314.1. So since this is an even number, I got to take the average of the 2 innermost data values. Well, the 2 innermost data values are going to be my 128.3 and my 134.5. So add them together and divide by 2 to get their average. So here we go, 128.3 plus 134.5. Divide that by 2, and we better get a number in between those. And we get 131.4. So that was my mean. My median is 131.4. So that tells me what's at the middle. So let's do that with the Midwest. So once again, we got to put these in order. So let's see, my smallest number is 87.8. Next would be 92.7. Let's see, 94.2, 95.2, 96.1, and then finally 228.9. There are 6 of them again. So once again, we got to use our 2 innermost numbers, which is 94.2 and 95.2. So add them together, divide by 2, and that answer has to be in between those 2, okay? So y'all, here we go. We got clear that 94.2 plus 95.2 gives me 189.4. Divide that by 2. And I get 94.7. So that's in between those 2 numbers. So 94.7 is the median for the Midwest. 115.82 was the mean. So I'll tell you what, since these means are bigger than the medians, anytime the means are greater than the medians, these graphs are going to be right skewed. They're going to have a lot more outliers to the right than they do to the left, okay? Let's see, what was next? Range. So y'all, the range ain't bad. All we got to do is find the biggest value, and I got them in order here. So the largest value is 314.1. So take that 314.1 and subtract the smallest value, which was the 104.5. So once we subtract that, we'll have our range, which is how wide it is, okay? So 314.1 minus 104.5 gives me 209.6. All right, so the one on the right for Midwest, their range is their biggest number, which was 228.9. minus that smallest number, which was 87.8. So let's see what that gives us. 228.9 minus 87.8. That gives us 141.1. All right, so let's see. Oh, that was a 141. You couldn't tell the way I drew that. So 141.1, 209.6 is the ranges, which means this one has a wider range, a higher median, and a higher mean than the Midwest did, okay? So check this out. Now for B. So you see why I wanted to go through this one. This one's got a lot of parts. For B, they want us to give the 5-number summary. So 5-number summary. And draw a box plot. Okay, so we're going to do that for each side. So over here, you got your low value is going to equal your median equals your high value equals lower quartile and your upper quartile. So we're going to do that for both of them. So over here, we'll have a low value, a median, a high value, my lower quartile, and then my upper quartile. I'm just going to use quarter instead of quartile because I'm running out of room. So the low value, median, and high value, we got all that already up here. So we got the range, which is the high and low values. And we already found a median, okay? So let's just fill in what we know. So the low value for the first one was the 104.5. The median was 131.4. The high value was 314.1. So now it says the lower quartile. Well, the lower quartile over here was these 3 first numbers. So the lower half of the data, which was the 104.5, 123.5, and 128.3. So what you got to figure out on that one is, since it's odd, the median will be the middle number for that set of data. So you only had 3 datas. So the median of the lower half is going to be the 123.5. The upper quartile is also 3 numbers. It's the upper 3 numbers or the upper half of the data. So y'all, what is the median of my upper half? Oh, I don't see that chat popping up. All right, so take these top 3 numbers. They're odd, so you're going to pick exactly the middle number. So what was that? 141.6. All right, so here's the thing. We're going to do that on the other side for the Midwest. We know their low value was 87.8. The median was 94.7. The high value was the 228.9. So here we go. The lower quartile is the median of the first three. Since that's odd, you're going to pick the middle number. And that was what, 92.7. Upper quartile, do the same thing with the upper three data points. It's odd, so we're going to pick its middle number, which is 96.1. So y'all, basically, that's what they was wanting us to do for B. The 5-number summary. Now we're going to draw the box plots for each of these. So let me pull this down just a little bit. And see how they want me to do that B there. All righty, so they'll have a scale down here. So I'm going to try to draw the scales they're doing. So we're doing East Coast, and then we'll do West Coast. So East Coast, the scale starts at 90 and goes to 330. And they're breaking it down to 130, 170, 210, 250, 290, and then 330. Now, let's draw the main box. So the main box is a rectangle that goes from the lower quartile to the upper quartile. So around 123.5. So I'm just going to estimate that about right in here. And then the upper end is at 141.6, which I'm just going to estimate right in there. I know it's in between that 130 and 170. That's going to be your rectangular box. First quartile, third quartile, which is the lower and upper. Now, the median was 131. So here's my 130. So 131 will be about right there. That's my median. Now, my whiskers are my range. My whiskers are going to go from the 104.5. So I'm just going to estimate that about right in there. So that's my first whisker. And then the other whisker is at 314.1. So y'all, that's almost to the end over here. So that'll be my other whisker, and my line will go across. So you see what we sort of got drawn. I'm going to show you how the answer is that they got. The answer would be C right here. See how this was sort of estimated when we was estimating those? This whisker's about, like they said, 91. This one over here is at about 3 something. Notice this middle one, they didn't even put the endpoints on the whiskers. Now this one's close, but these values are further right than they should be. Their first quartile on this one was about 135, 140. Remember, we needed that one to be at 123 over here. So watch the scales and see how they're sort of manipulating those, okay? All right, then we have to do this for the other company. So notice their numbers weren't as big, 314. So their scale has 80 at the low end. Then it has 120, 160, 200, and then they got a 240. So that's the scale that we're putting this one on. So let's draw the box. The low quartile is 92.7. So let's see, that's probably 100 there. So I'm going to estimate 92.7 right there. Upper quartile, 96.1. So if that's around 100, I would think. So that's going to be pretty tight right there. That's my rectangular box with my low and upper quartile. My median, 94.7. So if you notice, there's not a big gap in here. That's why this box is so tight. That 94.7 will be down in between those. So now's those whiskers. The low value, 87.8. Well, y'all, we're really tight with that. And I'm probably a little further out than I need, but that 87 is going to be pretty tight because remember that low value was 92, okay? But now my high value, 228.9. So let's see if that's about 220. I'll say 228 is about right there. So that little whisker is going all the way to the right. So look at their answers. The one I would choose on this one would actually have been B, because those values are so tight, it's making that look like a big, thick line. But notice, there's my 80-something, and then over here is my 220-something we said. This one over here, they don't even have a box drawn. They just got a bunch of lines going up and down, okay? This one is actually a box, but the lines are so tight in it, it's making it look like one big blur. So y'all, I'd probably pick B on that one. All righty, so that's your 5-finger summary, your 5-number summaries and your box plots. So let me see what they want next. Oh, so now we're going to need, so we got our data here. So the next thing they want is standard deviations. So this is part C. They want standard deviations. So I'm going to move this back up so y'all can watch me write, I guess. All right, y'all, so standard deviations. Let me write my data down, because remember, I'm going to have an X column, which is my numbers, 104.5, 128.3, 314.1, 134.5, 123.5, 141.6. Those are all my X's, and then I'm going to figure out the X minus the mean. Now remember, we know the mean. We said the mean for that data was 157.75. So that's going to be my East Coast. Over here, my Midwest, their X's were 96.1, 92.7, 94.2, 87.8, 95.2, 228.9. And then I'll figure out their X's minus their means. And we said the mean for this one was 115.82. All right. So here's the question. Since I've done standard deviations already by hand, let's do this one on the calculator so y'all can get good using that program. So I'm gonna clear my stuff. So the first thing I hit is the stat button. Right here, stat button, hit it. Edit's already highlighted, so I'm just going to hit enter. So I'm going to put my first row of data in L1, so I need to clear this out. So to clear it out, I arrow up. Now my L1's highlighted up there, and I hit the clear button. So watch what happens when I arrow back down. When I arrow back down, it's cleared out. So let's put this in L1. 104.5, enter. 128.3, enter. 314.1, enter. 134.5, enter. 123.5, enter. 141.6, enter. Now, y'all, since I'm doing two of these, watch this. I'm going to arrow right and get into the L2 column. In L2 column, I'm going to put this data. So I got 96.1, enter. 92.7, enter. 94.2, enter. 87.8, enter. 95.2, enter. And then 228.9, enter. So both of my data is now in the calculator. So I'm going to hit second, quit, and quit that screen. So now I'm going to let the calculator give us the standard deviations for both of these. Now you could do these by hand, remember, if you like doing that. So remember, this was what I called L1, and this one over here was my L2. So we're going to find a standard deviation of list one first. So we hit second stat, arrow over to math. Once you're in the math column, arrow down and grab the standard deviation. So that brings it on the screen. Now you hit second stat again to get L1 list. L1 is highlighted, so hit enter. So now it's going to take the standard deviation of the first list we made, which gives me, so let's see how far they want me to round. We're going to round them 2 decimal places. So that would be 99.06. Now, let's find the standard deviation of the second list. So remember, second stats, go over to math, arrow down and get the standard deviation, enter. This time we need to get L2 because that was my second list. So second stats, L1 is highlighted, so arrow down 1 to get the L2 highlighted. Now that the 2 is highlighted for L2, hit enter. And it's now going to take the standard deviation of the second list, which is, what did we say, 2 decimal places. So how about 55.48? All right, so a lot more deviation with this one than we had with the one on the right. All right, so I need to see what's next they're asking. So the standard deviation of the coast, the Midwest. So for D, they say apply a rule of thumb. So I showed y'all the rule of thumb the other day and estimate the standard deviation for the data points. So the rule of thumb said that the standard deviation was approximately equal to the range divided by 4. So y'all, we had our ranges a while ago. The range of the first one was 209.6. So we're going to divide that by 4. And then on the right side, the range for it was 141.1. We'll divide that by 4. So the rule of thumb says that you can divide the range by 4 to get an estimate of the standard deviation. So let's see if that's true. So over here, 209.6 divided by 4 gives me 52.4. So that's pretty much off from that 99, okay? So the estimation wasn't really close to that one. Let's try this one, 141.1 divided by 4. That one gives me approximately 35.28. Little closer on that one than we did the first one. So then they say, how well does the rule work for each case? Well, these are some long ones, ain't they? I'm trying to figure out how much longer this problem is, okay? So I think we're getting close to the end. It looks like we got this one and then one more question. So really what I would say on these, 52.4 is not nowhere close to that. And the reason this is not a very good estimation is because we got a big outlier here. That 314 is pulling our data way out. So it's making our standard deviation a little off using the rule of thumb. And I would say this one's off pretty bad too, 55 and 35. But what's hurting this one? It's got a big outlier. So neither one of these was really a good case. And estimating, okay? All right, so I think there's one more on this thing. Number E. Well, y'all see now why I wanted to work through this one, right? And then y'all gonna have about 2 of these to do. So I definitely wanted to get through one of those to show you what all was happening. All right, y'all, for E on that. Based on all the results, compare and discuss the 2 data sets in terms of their center and variation. Choose the correct answer below. So we had data somewhere. So we're looking at the mean data. So the mean of the East Coast was 157, which was higher than the mean for the Midwest. So the cost of living was higher definitely in the East Coast than Midwest. Because remember, that's what they were looking at, cost of living. What else are they looking at on these? So I'll just show you their answers. So let me pull this up. So their answers were on the bottom there. The mean of cost of living for the East Coast country counties is higher than that for the Midwest. Well, we got that. The mean was higher, which means the average cost of living for the East Coast counties is lower. Well, if their mean was higher, then that would really mean that their cost of living is higher. So they sort of threw you off with that lower there. The variation of the cost of living for the 6 East Coast counties is higher than that for the 6 Midwest counties. So the variation was that standard deviation. So they're saying the East Coast was higher than the Midwest. So let me pull that page up. So East Coast was first, Midwest was second. So they're saying the variation, which is the standard deviations of the 6 East Coast, it was higher definitely, which means the level of cost of living in most Midwest counties varies in a larger range. Well, that part was false because the Midwest didn't have the bigger variation. It was actually the East Coast. The mean cost of living for the East Coast is higher than the Midwest, which was true. We had a mean of 157 versus a mean of 115. So the mean was definitely higher for the East, which means the average cost of living for the East Coast is higher. Definitely, that's what it means, right? If your mean is higher, then your average is higher. And since they're talking about cost of living, that was the only choice we could take. And then this one's false because you can't tell that the variation is going to be greater just because the mean was greater, okay? So y'all, that was a taste of a little sample of what y'all got coming up in 6B, okay? So like I said, they're going to have a few problems where you go to and they're just sort of asking definitions, a few problems where you think, is it possible or not? Then you're going to have to do a few problems with the standard deviation. And those are the ones that take the longest amount of time because there's so much to do when you're doing them by hand. Oh, y'all, that's a long one there, right? So that thing had it had E parts, but you had to double each part. So that made that double. And then some of the parts had a 2 or 3 parts you had to answer on them. So there's probably, oh, you're filling in at least 10, 20 blanks on that one. All righty, y'all. So other thing I wanted to remind y'all was on your projects. I wanted y'all to remember, try to find one of those questions that you can ask anywhere from 20 to 25 people. The questions were not bad. It was like, you can use questions like, how much time do you spend on your phone a day? How many hours do you study a week? How much do you spend on a certain bill, your phone bill or something? Find one of them questions you like, and then figure out how you're going to ask 20 to 25 people. I would probably just put me a Facebook post or something, and hopefully my friends would respond to it with some kind of answer. And just tell them you're doing like a stats project for class. And people volunteer for those pretty good. They'll get on there and want to help you. All right, y'all. So, I took y'all a little longer than usual today. So, y'all have any questions? All right, y'all. So the main thing this week was 6B support and 6B regular class homework. So try to knock that out. Remember, by Sunday night. If you still have problems on that 6B, we'll stay a little longer Monday and try to get that worked out, okay? But I'm really hoping y'all have seen enough examples of me doing that standard deviation that you're sort of getting used to it now. All right, so I'm gonna stop this recording.